In this lesson, I will look at stalling, lift forces, and airspeeds. The green lines extending from the plane are the lift vectors indicating direction and force of the wing's lift. As I climb the plane, you can see the lift reduces and airspeed decreases until the plane stalls and begins falling. As the plane stalls, I dive the nose to increase speed and lift and regain control of the plane. In Lesson 4, I look at how flaps and landing gear affect airspeed and drag. As I extend the landing gear, the drag underneath the plane increases, which dives the nose and increases the plane's airspeed. This is not what I expected at first, but it increases the airspeed. I use the data recording feature on XPlane to create a graph of when flaps are extended and engaged versus not engaged and the airspeeds in each instance. Here's the screenshots from each flight and their corresponding numbers. Flaps are used when landing to increase drag, slow the plane down, and increase lift at slower speeds. In this lesson, I measure the different drags and lift when flaps were up and down across 3 flights, each with flaps up and down. When flaps were up and not engaged, the average airspeed was 161 knots, lift was 1,427 newtons, and drag was 44.5 newtons. When the flaps were engaged, the airspeed changed to 146 knots, lift was 1,745 newtons, and drag was 263 newtons. This shows how flaps increase lift while also increasing drag and lowering airspeed, all to help a pilot land the plane safely.